or to astonish people of the modern era, but yet today I am bravely going to try.
People are fucking That's why they're fucking choking out and fucking dying and shit. Like all these diseases are going down, dude.
There are a number of laws of conservation in our universe. Conservation of mass, of energy, and so on. These laws make intuitive sense on a macro scale. Within a closed system, things cannot simply magically be created or destroyed, they can only change. When we approach the subatomic level, however, things get much less intuitive. Take the example of a decaying subatomic particle. The particle has no spin, but it decays into two spinning particles. Because of the conservation of angular momentum, if one of the particles is spun up, then the other must spin down. This makes sense first, until you consider that this must remain true no matter where those two particles travel. If the spin-down particle travels to the moon, 385,000 kilometers away, it must remain spinning in the opposite direction of the particle on Earth. These particles are quantum entangled, and they cannot be described separately from one another. For a more concrete example, let's say that you travel around the world and you present a friend of yours in another city with 2 cups, 5 dice in each cup. Let's say your friend keeps one of these cups and you go home with your cup and your 5 dice. Now let's imagine that these 2 cups and die are quantum entangled.
No, dude, you just want to take, you just want my 5 dice to run away with it.
Slam it down at the table,
so you can have a fucking sissy-gasm,
and you see that all of the dice read the number 2. Your friend's on the other side of the world, he's done exactly the same thing.
You don't even know what to do with them.
You know that all of his read 5.
I did.
It doesn't work with dice, it's just an example. Scientists are extremely interested in quantum entanglement because of its potential applications in a number of fields. The most basic uses and currently the most promising are in quantum computing and quantum cryptography. If you thought internet puzzles like Cicada 3301 were hard already, just imagine the nightmare that they will be when quantum cryptography is thrown into the mix. There's also the example used earlier, a particle here on Earth and a particle on the moon over a full light second away. Information, like all things, is supposed to be constrained by the speed of light, but quantum entanglement has the possibility of enabling faster than light communication, which would be groundbreaking in a way that we can't possibly even imagine. And if you're more the science fiction type, this may hold secrets to teleportation as well. Experiments in quantum teleportation date back to 1997, and further experiments have become more reliable, but so far this only refers to the teleportation of information, not matter.
Shut up, dude. It's matter, dude.
The Kalatz conjecture is named for mathematician Lothar Kalatz. He introduced the idea in 1937, 2 years after receiving his doctorate, and he probably immediately regretted it. The idea is pretty simple. Take any positive integer that you can think of. If the number is odd, multiply it by 3 and add 1. If it is even, divide it by 2. Repeat this process until you eventually reach a repeating loop of numbers. This seems pretty simple. In fact, it's so simple you could explain this problem to an elementary school student and they would probably be able to process it. Let's take the example of 5 as a starting point. 5 is odd, so we'll multiply by 3 and we'll get 15. Plus 1 gets us to 16. 16 is even, so we divide by 2 to get 8, which is even, so we divide by 2 to get 4, then 2 to get 1. Now we're back at odd numbers, so we multiply by 3 to get 3. Plus 1, we get to 4, then 2, then 1. Then we have a loop that repeats the sequence 1, 4, 2. The conjecture is that every single positive integer will always wind up at this same repeating sequence. On the surface, the Kalatz conjecture, also known as the 3n plus 1 problem or the 3n plus 1 conjecture, seems simple enough. Even if you hate maths with every fiber of your being, you likely still understood the concept of it. A maths problem that a second grader could do hardly seems like it would qualify as mind-blowing. There's just one thing. It's been 85 years, and nobody can prove this theory. So how can it be that a simple mathematical process with only 2 rules is completely unsolvable? Aspiring mathematicians have ruined their careers by pursuing a proof to this conjecture. Computers have checked every starting number from 1 through to 300 quintillion, which is 3 followed by 20 zeros, and thus far every single number has reduced down to the 1, 4, 2 pattern. Still, this doesn't prove anything. If one of those numbers ended in a different loop, then the conjecture would be false and we could all go home. But since that isn't the case, we're no closer than we were before. The first 300 quintillion numbers all followed the same pattern. But what if the exception isn't 300 septillion, octillion, or even sextillion? There will always be more numbers, so it's impossible to brute force a proof in this way and a counterproof. It seems innocuous on the surface, but a simple number game that could have been created by a child managed to break mathematics for nearly a century. Don't think that the Kalatz conjecture is always cracked up to be. Well, give it a go yourself. In 1983, Hungarian mathematician Paul Erdos offered a $500 prize for anyone who could solve the conjecture. Not very much money today, but good news. In July 2021, Japanese company Bakwaj upped that prize to 120 million yen, or just over $1 million, making it the highest bounty for a mathematical proof ever, but just barely. In addition to the Kalatz conjecture, there were 7 problems known as the Millennium Prize puzzles, each worth $1 million to who could solve them. To date, only one has been solved, but Russian mathematician Grigory Perelman declined the award in 2010 when it was offered only to him and not also to American Richard Hamilton, on whose work Perelman's proof was built. It's a bit of a legend, really.
What the fuck?
No, you did not just accidentally switch the channel to an Ancient Aliens documentary. Panspermia is the theory that life exists throughout the universe and it is carried to planets, including Earth, by way of meteors, asteroids, comets, etc. Panspermia is a fringe theory, but it is not completely without merit. The idea is not that aliens came and colonized the planet, building pyramids and then piecing out new generations of mankind baffled, but rather that microorganisms crashed to Earth from celestial bodies and were able to grow and evolve here. The otherwise outlandish theory began picking up credibility in the 1980s and 1990s with the discovery of extremophiles, microscopic organisms that are able to live or even thrive in inhospitable conditions that were believed to make life impossible. There are various organisms that have been found that prefer sulfuric acid to water, are unfazed by temperatures above 121 degrees Celsius or below negative 25, and they don't even notice levels of radiation that would kill a human in mere minutes. But these extremophiles traveling on an asteroid through the vacuum of space would just be business as usual. While not considered a true extremophile, there is also the beloved tardigrade, or as they are more colloquially known, water bears. Water bears can survive any and all of these conditions, but they merely endure them. They don't thrive, hence their exclusion from the extremophile label. Just like they withstood extreme conditions, water bears were able to withstand this derision and exclusion as true extremophiles by becoming the first animal to survive in the vacuum of space. In September 2007, water bears were taken to low Earth orbit and exposed to the hard vacuum of space, UV radiation and all. Some were dehydrated and some were not, and after 10 days of being tortured for science, it was time to bring these adorable little critters home. Those that had been hydrated when they went into space almost entirely died, but of the dehydrated samples, nearly 70% returned to life after being rehydrated. These seemingly invincible specimens had an extremely high mortality rate following their reanimation, but many of them were able to produce viable embryos. In short, if dehydrated water bears were on a space rock that fell into the ocean, they may have been able to colonize the planet. While it's not the most likely theory, the evidence suggests that it is absolutely possible that microbial life on Earth crash-landed here from beyond the stars. Critics of this theory cite that it is unprovable and untestable, and especially that it doesn't answer the question of how life originated. Critics also say that the coelacanth went extinct 65 billion years ago, but cryptozoologists proved them wrong in 1938. So, shows what all those scientists know.
They don't understand how time works. Time is not linear. Like, you can suck on my ass. You can suck on my prostate.
Our universe seems pretty stable, but what if it could be even more stable? That is the question behind false vacuum theory. This one gets extremely technical, so we're going to stick with a really broad overview today. Put it very simply, in quantum field theory, a false vacuum is a hypothetical vacuum that is stable, but not in the most stable state possible. In quantum theory, the more massive something is, the less stable it is. The entities naturally want to decay to a more stable state. If our universe is in a metastable state and not a truly stable one, the decay to a stable state could be devastating to say the least. Or maybe it wouldn't be. We have no idea what a more stable state would look like, so it's impossible to know what exactly would happen. It's possible that the elementary particles and fundamental forces of the universe are similar enough to what they would look like in a truly stable state that life would go on largely as normal. It's also possible that the new laws of gravity in a more stable state would cause the entire universe to collapse in on itself, which would be bad. The extreme scenario is less likely, but it is unfortunately much more likely that all life as we know it would immediately cease to exist rather than us being rather okay. So, well, we probably wouldn't care what happened to the rest of the universe at that point.
No,
or maybe that's
fine.
a bit self-absorbed.
A
theory based on a hypothetical metastable state existing sounds like it'd be difficult to measure, but unfortunately, that's not the case. The best way that we can attempt to guess whether or not we are in a false vacuum is by measuring the mass of the Higgs boson particle. Infuriatingly, the mass of this particle lands right in the middle of definitely being stable and maybe being able to decay to a more stable state at any moment. The universe has persisted in this state for billions of years, and it may well just persist for billions more. Or maybe it will decay to a more stable state before you finish watching this video. The one upside is that if the false vacuum were to decay and the stable universe was not hospitable to organic life, we'd all be long dead before we could even detect a change. No use being filled with existential dread over something you can't control, predict, or prevent. Still quite scary though, isn't it?
Don't fucking eat me, you stupid fucking mortals. Piss me off.
This one seems sort of obvious, right? The universe, which contains literally everything, is really big. Good job, Simon. You have provided us with such mind-blowing stuff. But seriously, have you ever actually thought about how big it actually is? Now, Earth is pretty big, at least relative to our myopic human perspective. The sun is so large that roughly a million Earths could fit inside it. Then there's all the other planets and such in our solar system, but that's just our solar system. In the Milky Way galaxy, there are estimated to be another 100 billion planets and another 100 billion stars. As technology advances, so does our understanding of the vastness of the universe. If you were to ask Aristotle how many stars there were in the sky, his answer would likely have been too many to count. Telescopes have expanded our knowledge of the surrounding celestial bodies from, I don't feel like counting them, to hundreds of billions. And that's just the Milky Way. Current estimates from the Hubble telescope say that there are 100 billion different galaxies
has nothing to do with your
universe,
understanding.
but that with even more sophisticated equipment, we could likely see evidence of 200 billion. So that's hundreds of billions of galaxies, each with hundreds of billions of stars and hundreds of billions of planets, each of those being absolutely massive. And that doesn't account for all the asteroids, comets, and other miscellaneous stuff just floating around in space. And then consider the fact that most of space is empty. If you set off a spacecraft heading in a straight line away from Earth towards the edge of the universe, you would almost with a 100% chance reach the edge of the universe without hitting anything. Because space is super empty and it's super big.
It just keeps shooting into A1, 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 A1.
I really hope you enjoyed today's video. If you did, I'm going to put another space-based video that we've done on the screen right now, which, why not click it? Find it if you like that one too. And thank you for watching.
Fucking Christ, holy shit.